Okay, let me introduce you to Stanley's Fat Max. I've had it for some time now, but this has a little bit of a curvature on it, this driveway. I could use a string line, but the curvature might get me. Or I can elevate the string line. In this case, it's a laser, and it's elevated. So it's elevated, so the difference is, this is 4 inches, as you can see it pegging. The laser, see it, 4 inches. That little white line moving, that's a laser. On this side, the elevation is 3 inches. Let's see if I can get it to move a little bit, see it? So now we're down at 3. So you can see a string line could be troublesome. So a Fat Max, something like this, is a lot faster than Transit or anything else you're using. And it shoots down the line of this one here that's lining up. See the white line again? Let's see if I can get you the white line. And right there. So this is the line, and that's square to that one. It puts off a laser up top, below it, and 3 sides, not the back side. So over here, translating to the other hole, the other cutout that needs to be done, it translates right in line with this one, with this guy here. And then you just use a square. Well, you can just use a square, right? But you have to make sure that the square is still in line with that. So simply come out here, and where your 2-foot square is, line it up, mark it, and now you've got a square from this side. You can square off of this, go over 2 feet, square off. You don't need a laser anymore. So just showing you that, how to get these parallel to each other and resolve the elevation difference. This saw, don't buy it. If you guys are interested, don't buy it unless you're cutting some pipe or some very small stuff. That's gone through 3 batteries, and this is the 4th battery. So it knocked out 3 batteries, and it took the 4th one to get full penetration of 5 inches. 5 inches, beautiful diamond blade, so it's not, it's a good diamond blade. So, no, this beast is not really a beast, but it's great if you got to cut some ductile pipe or something like that. I mean, whew, you don't have any, if you're inside, it's great because there's no fumes you have to deal with. But this is not a, it's pretty powerful speed-wise, but it knocks out a battery in no time at all. No length at all. I mean, that's only like 2 foot. This guy here, just so you know, it's not quite 2 feet. It's 27, and this is my 23. Now this is going to be for a lift. This is that was the outdoor lift location, and inside will be an indoor lift location. These things will bolt down and pull away. So this will get cut near the back. This will have to get cut also because it's so close to an edge. Or I'm just worried about it tipping over, and I just will go with the back side back here. Now it can rock left and right, so definitely need another side there, another side here, and the front just to secure it to some degree. They use 7/8 inch what I call wedge anchors. They expand so they can crack your concrete, but all the work is being done down here, and where these two lock together. This just gives you depth. So it gives you depth below the surface of the concrete. Let's say that's the edge of the concrete. That's the control joint there. So that all the work is done down here, and this is your protective cone from here upwards that will protect it from its blowout as the rotation happens. So this is all the area would have to fail here. So you make sure you use the right size bit. In this case it's specified 7/8, and that's not 7/8. I have a 7/8 coming in today, hopefully. That's why these holes aren't drilled. I'm going to stay with the specifications of that bolt, that manufacturer. But moving on. Oh, so yeah, so that's the outside and inside. So I did these little ramps. I've got to continue. I've got to figure out what this pipe is It was discovered under the apron here. So until then, until I figure that one out, it's just going to have these ramps here. No hurry to figure it out. Hey, got around without knowing me all these years. So at this property, so this gets cut out. That's going to be the hole for the uprights. Let's see if I get that right. And that's outside to outside. That will allow headroom from here to the nose of the vehicle to be over to, with the garage closed, to be outside. So it gives me an outside location and inside. If you notice where I put it between the driveway so I can drive into the garage without hitting the bolts. I'll make up a block of wood because the bolts will be above a bit. I'll make up a block of wood or something that will protect those bolts as they protrude through, permanently protruding through. I'll show you the bolts. So here are the bolts, and what I did, well, there'll be another one there. I'm only going to go with 4 to hold it down. I'll use 2 more just for wedge anchors, real shallow. Most of the work are going to be done by they're all going to be clamp forced down where they will be equally distributed on the plate. But any rotation towards the car of the top of the column, the MaxJax, any rotation, so this way, if you look at what I'm doing here when I pull on this, as the car goes up, it's going to put that torque on it. You see, the rotation is in the front. So the front, all I got to do is pin down the back. As you can see, that's where it needs to be locked down. So the long ones will go in the back, and the 2 short ones will go on this right here. But most of the work will be done by the long. Well, they'll all be forced, but the stresses will be on the long bolts in the back. So these will go down, secured in the concrete. This will all be concrete. That much cover on there. Rebar is kind of a waste for what I'm going to be doing, because this will be again, this is anchored down the bottom. So all that concrete cover is great, and this will act as reinforcement too. And what I'll do is a little trick. I'll put this down, and this will be the ones up front, up high. I'll give them a couple of stirrups. Down low, these will get stirrups also with some rebar towards the front of it. They'll be stirrups, so the column will act as one if it starts to rotate. Now, this will be dug out, and a little bit of bell will be putting it at the bottom of it, a little bell footing. So this will all be solid concrete, and if it tries to rotate, it's got to rotate this whole hunk of concrete, rotating it. Sorry about the white balance. And it won't be able to do that rotation because the soil here will be in the way for trying to crush the soil here. Now when I dig it down, I'll inspect that soil. If that soil is, or saturated for some reason, then I'll reevaluate this, because this is just an extension of that column into the ground, and I'm worried about rotation. It's not really a ballast to hold the vehicle. It's just a column in there, and it's being resisted pinned by not being able to locate, pinned if you will, by not being able to rotate out of the way. Remember, this goes up. The top one goes up, but this is all the way in the ground. So she can't rotate if it's pinned against the earth. Again, it would be a bell footing also, not just straight down. At the bottom, I'll bell it. I'll give it a foot, if you will. So that's all about the rotation there. I should not see any rotation at the top of this deal, but I do have plan B if that goes south. You can always anchor back the top part to take care of the moment of the rotation. So I could always anchor back from there, back in with a coil, Healy coil in the back, and I do have those. And you just put stress on the cable, and that's it. Now, that's the rotation. I'm worried about that direction. Am I worried about left and right? I sure am. I sure am worried about it rotating left and right. This will be level. This will be level with the one over to the right. And that will be, so it's a 1 inch difference. So one way or another, the 1 inch will be made up for to make that the plates level from one to the other. Okay, what else can I say about that? So you're worried about the rotation. I told you about plan B. I don't think I'll be into plan B, but there's no way I'd be digging this footer out and going with a ballast system. No way. It's going to be with the resolving its overturning moment with either a couple of cable stays, which would be ×3. Here's a kicker when you're using these lifts. You say you go to torque on the car, you can create some serious rotation and torque in the vehicle that can cause the lift to want to rotate this way. And that's why we want the bigger anchors. I don't like those wedge anchors. I have other lifts, stands coming in that when you put the vehicle up, it'll actually be still supported with additional stands, 2,500 pounds, 2,250, and 4 stands coming in that will, so when the car's up, it will get braced also. So this will be, in addition, redundancy to the lift. So it keeps it stable when you're torquing on the parts or whatever you're doing, having a little fun on your vehicle. This is obviously outside. The car can fit inside the truck. A little troublesome with this headroom. This won't have the headroom problems. All right, so moving on, loading this video up for you, and I don't know, by the time you get this video, the project will already be done and worked on, and then I'll load a vehicle of the completed project, of this system. So again, I have 2 more. Okay, it's 3. So I got 6, 2 large, 2 here, and 2 in the middle. The middle is short, and that's what I was trying to get to you. Is that I staggered the stresses with this way. I could have just went all the way down and made them equal ×6. All the stresses at the bottom there equal. But I like the idea of staggering it. So it's staggering it. We've got the 2 in the back, 2 in the front, and the 2 in the middle are higher up. And it's got the least amount of, it's pretty much near the neutral axis. So it's got the least amount of duty it's going to do. This is like your redundant system. As that one, if that one went before, it would be able to take, it would have to go to this one next. But if that one ever fractured for some reason, this would pick up with the balance of the concrete, still having to rotate from that location. So I staggered my stresses, if you can understand that. Take care. My stress locations.